This introduction says the introduction from the last section stated that there is a concert series coming to Sioux Falls and the price of each ticket includes the following: admittance into the concert, supper, and a night stay in the campground. A group of friends are planning on going. The cost of each ticket is $80 and they are budgeting $120 total for the price of gas and snacks for the trip. So we decided that if we did not know how many people were going to the concert, we could write the algebraic expression 80p plus 120 to represent the cost, where p represents the amount of people going. We now know for sure that there are 7 people going on the trip. So question number 1, how much will the trip cost? Well, if you remember, when we set up that algebraic expression, we understood that we were actually kind of setting up a function machine where we were going to take some number, we were going to multiply it by 80, and then we were going to add 120 to whatever that value was. We set up the machine, but we didn't turn it on. Well, today we are now going to turn it on because we know what number we are going to throw through our machine. So this states that we are starting with 7. We're going to turn the machine on, drop it in, and we're going to go through the different steps. 7 times 80 is $560. Then we have to add on our gas price. So 560 plus our gas of 120 is going to give us $680. So the way that we can visualize it dropping through our machine, algebraically, we started with the expression 5p plus 120. Okay, we understand that that equals the cost of the trip. Now we're going to go ahead and take that 7 and substitute it in for our variable. So now instead of p, I'm going to put a 7 there and add that 120. And to evaluate it, I know that 560 plus 120 equals $680. So the difference here is that we are taking our expression and we are now evaluating this equation. So we are solving for it. Evaluating and solving are synonymous. They mean the same thing. Okay, so let's go ahead and look at this next one. It says, after the concert, the group of friends see a poster that states the main band, Two Turtles and a Sloth, who are amazing, are having a special concert in a few weeks. To make it even better, the concert is in Pierre, so they don't have to drive. The cost of tickets is $68.95 for We Love Music members and $78.95 for non-members. So step number 1, we're supposed to write an algebraic expression that represents the cost of the tickets. Again, we should be getting pretty good at this whole algebraic expression. This one's a little bit different because there's actually 2 unknowns that we have. We have these members of this group and non-members, and we don't know how many of each are going. So I'm going to say that when I deal with members in my equation, I'm going to use the variable n. When I deal with non-members, I'm going to deal with the variable n. Does it matter that we have more than one variable? No, because they just said write an algebraic expression, and we understand that expressions deal with variables. So looking at this, it's $68.95 per member. So I'm going to say that we have $68.95 for each one of those that are going, and I don't know how many that is, so I'm going to say m. I have to add that to $78.95 for the non-members, and again, I don't know how many, so I'm just going to write that n. There's my algebraic expression that has 2 terms with 2 different variables. Now looking at 3, it actually looks like we have to evaluate it now. It says, how much would the total price be if 3 of the friends are We Love Music members and 4 of them are not? So we're going to take the information we know and substitute it in for those variables. So I know that I have $68.95 for my members. It looks like we have 3 of those that are members. So we have to buy 3 of those tickets plus 4 tickets for $78.95. So this section is actually quite straightforward. The reason why I included it so we can start getting used to using our nice graphing calculators. So give me a second to pull my calculator up. Okay, for this class, I'm going to use the TI-83 calculator, which isn't as fancy as the new TI-84s, but it's still definitely doable. The nice thing I like about these graphing calculators is we can plug this problem into it exactly like this. So I can state that I have 6895. I know that I'm multiplying that, but I don't even have to use that button. If I hit the parentheses, which are above the 8 and 9, this calculator understands that I'm multiplying that by 3. Plus 7895, don't need that multiplication button. I can just go ahead and put that 4 in. And I know that that parenthesis runs on another line, but again, calculator understands what I'm doing. So grand total of 522.65. I don't consider it lazy, but I like to use my resources. I like to use that calculator as much as possible for nice problems like this where I need a quick answer and I don't want to hit at tons of buttons. The least amount of buttons I can push, the better. So again, we're going to understand how to evaluate expressions and equations today, as well as get used to how to use that calculator. Go ahead and get out the notes and vocab for this section. Okay, objective is to evaluate linear and algebraic expressions by substituting integers for unknown quantities. And to find the cost of admission, remember that we multiplied those two together and it must have been evaluated. So to repeat that, to evaluate an expression means to find its value. Looking at example 1, we're supposed to evaluate 3 to the 5th. And this is a power. So we understand that that exponent 5 means that we're supposed to take 3 and multiply it by itself 5 times. So this is one way to find the answer. Another way is to use our calculator. When we use these calculators, you can just keep working and have this other answer up here. If you don't like that, hit the clear button. But we can put this problem into the calculator with the least amount of buttons as possible. And to do that, we're going to use this caret button. This caret button is the to the, it's the power button. So I'm going to say 3. I'm going to hit the to the 5th. On a TI-84, that's going to look a little bit different, but if we go ahead and hit enter, we get 243. Is that the same as hitting 3 times 3 5 times? Well, let's find out. Yes, it is. But look at which one of those was much quicker to do. So again, caret button is that exponent. It understands that we're taking it to that power. So 3 to the 5th is 243. We evaluated because we found its value. Okay, go ahead and use your calculator. Use that caret button for guided practice 1. Should have been nice and simple looking at my calculator and what I got for answers using that caret button. Okay, let's look at this next section. It says the numerical expression that represents the cost of admission contains more than one operation, where we had to multiply that first piece, multiply the second, and then we added them together. The rule that lets you know which operation to perform first is called the order of operations. They have some nice steps here, but many of us know this as PEMDAS, which is the order of operations, where the grouping symbols are parentheses, the powers are exponents, then multiplication and division. Notice it says left to right. So if there is 2 multiplications in there, start with the left one first. And then addition, subtraction, left to right. The really nice thing about these calculators is that it understands the order of operations. So looking at example 2 and looking at order of operations, let's figure out what we're supposed to do here first. Evaluating this. There are no grouping symbols. So the next thing we have to do is the exponent. So it looks like we had to do 2 squared first. Calculator, notice that it actually has a squared button here. So if you hit 2 and squared, it's going to square that 2 squared. So I was supposed to do that first. So there's my exponents. Then I'm supposed to multiply and divide. Okay, so here's division, which means I have to take the 8 and I need to divide it by what I got there, which was 4. Then I have to do addition and subtraction. Notice there's 2 in here, so I'm going to work left to right. So I should take 16. I should subtract what I got, which was 2. Then I should take that answer and add it to the 14 here. Okay, so I ended up with 28. Again, a lot of steps. My goal with using calculators is to use the least amount of buttons as possible. So I'm going to go ahead and plug it in exactly how it is in the calculator and see if it gives me the same answer. 16 minus 8 divided by. Notice when I hit that divided by sign, it actually gives me a fraction symbol. That's okay because division and fractions are the same. So I'm going to divide that by 2, use my fancy squared button, plus 14, and jury says 28. So is that lazy to use the calculator like that? I say it's just using your resources. So either way, we're going to get the same answer. All right, go ahead and try guided practice 2. All right, getting used to calculator work, you should have got 82 and 0 for that one. Whoop, moving on, it looks like I have answers. Don't look at those. Okay, again, we're supposed to evaluate each of these expressions, noticing that we have grouping symbols in there. So this, again, we can still use calculators. We're just going to get used to how to do that. All right, those grouping symbols are above the 8 and the 9 that we already know. We've used those before. So let's go ahead and just plug this in. 4 divided by 2 plus 5, grouping symbol. The calculator understands that that's multiplication. We should end up with 22. So here's another question. I know what 10 minus 6 is. I understand that that's 4. Could I put that into the calculator right there? Sure, that would be fine. You're going to get the same answer. So yes, sometimes the calculator does make us too lazy and we rely on it too much. If you can do some quick computations to help yourself out, go for it. Otherwise, this one is 22. Okay, notice B has some kind of crazy stuff going on here. We have brackets as well as parentheses. Calculator has those. So if you look under the multiplication and the subtraction sign, you see brackets. Notice how they're yellow. So that means in order to get those brackets, we have to hit the second button in order to get to them. So I'm going to type this in exactly how it is. 6, I'm going to use that first bracket, so second multiplication sign, 32 minus, here's my parenthesis, 2 plus 3. Do I understand that's 5? Yes. Surely could have put 5 in there. Square button, and then I'm going to close my bracket. And of course that didn't work. So what did I do wrong? 32 minus 2 plus 3 squared, close the bracket. This is what happened. It's not going to let me go back up. Okay. That actually is a good example of when this sometimes doesn't work. So 32 minus 2 plus 3 squared. Okay, so here is a tricky part because technically my cursor is up in that squared position, so I have to hit the right arrow in order for it to drop out of the exponent. Then I'm going to close my bracket. And it should help by, what on earth? Give me a second here. Okay, as embarrassing as it is that that didn't work, it's a good example to show that sometimes calculators aren't as fancy as they need to be. But I usually use these brackets right here underneath there. I had thought that those brackets would work. So we're going to use these brackets instead that are above the actual parentheses. So I'm going to hit 6. I have to hit that second button, 32 minus, and then again just the parenthesis, 2 plus 3. I'm going to square that. I'm going to close the bracket. Even though it doesn't look the same, I'm going to hit enter, and it does give me brackets around that, which tells me it's a solution set, which we'll talk about in a later section, but 42 is the answer on that one. So our brackets are going to look a little bit different, but when you do see those, you can use the ones above the parenthesis, which is basically just a second bracket. Okay, looking at this one, since we have division, one thing that we have to include in this problem are parentheses around the numerator and the denominator. That's one thing that the calculator doesn't understand, is when the numerator ends and when the denominator begins. So those parentheses will help it understand that. So looking at this one, we have a parenthesis. We're back to the power of 3, so we're going to have to use our caret button, minus 5, close parenthesis. And again, look at this. What's 15 plus 9? I know that's 24, so I'm just going to put 24 in there. Least amount of buttons as possible. Okay, I get kind of an ugly looking answer. So this is usually the rule. If the problem is set up as a fraction, you need to write the answer as a fraction. That's not a fraction. So another fancy thing this calculator does, if you hit this math button, which is over here, I'm going to ask it to change my answer to a fraction. So I'm going to hit the 1, then I'm going to hit enter, and it's going to tell me that that decimal actually represents 1/8. Okay, some pretty fancy things about the calculator. So again, if the problem is written as a fraction, write the answer as a fraction. All right, go ahead and mess around with your calculator and try guided practice 3. Okay, here are the answers you should have got. Look at 3C. Notice that that would have been a huge mess to put in the calculator like it did. So I did some quick computations. I understand 4 plus 5 is 9. So 9 squared divided by, I really didn't want to deal with this, but 7 minus 4 is 3. 3 times 3 is 9. So sometimes using your brain a little bit more than the calculator does help you save some frustration. All right, moving on. I do not know why I already have the answers to these guys. Thought I got rid of them. Okay, we're evaluating algebraic expressions still, but it says to evaluate an algebraic expression, sometimes we do have to replace the variables with their values. Then we find the value of the numerical expression using that order of operations, which is what we did when we needed to find out the 3 members and 4 non-members. Okay. The thing that I do to start with is I go ahead and rewrite this problem with big parentheses or big holes every time that I see a variable. So I'm going to write 3. There's a variable, so I'm not going to write the variable. I'm just going to put parentheses in there, and I know I have to square that. Plus 2. I know I'm going to plug something in for that y. I know I'm going to plug something in for that z. Kind of a big deal for later when we start dealing with negatives, which is totally going to change the problem if you don't have those parentheses in there. So getting used to it now might be a good idea. Now I'm going to just go ahead and plug in the values that they tell me. They tell me that x is 4. So I'm going to put a 4 in this parenthesis. They tell me y is 5. They tell me z is 3. Now this is what I'm going to put into the calculator. Using those parentheses, they're not always needed, but again, getting used to them now is going to help save some time later. Notice that I closed that parenthesis before I squared it, because that square deals with the whole value of x. Plus 2 times 5 plus 3, close that parenthesis to the power of 3. So grand total of 85. Again, always, especially when we're trying to plug in some values for those variables, good idea to put those parentheses in first and then plug in the answers. But grand total of this one should be 85. All right, with that in mind, go ahead and try guided practice 4. Okay, should have got 23 and 26 on that one. Again, I know that that's parenthesis crazy to do it like that. So if you notice on 4B, I didn't put the parentheses around the 12 right here because if there is no other operation being done to that value, you can leave those parentheses out. But otherwise, since I was multiplying that 4 by a 5, since I was multiplying that 3 by a 6, use those parentheses, especially when you're dealing with powers. Alrighty, moving on. Looks like the last one. Let me get rid of answers. Whoops, that did not work. Okay, these problems are dealing with geometry because we're looking at formulas here. It says science on a sphere demonstrates the effects of atmospheric storms, climate changes, and ocean temperature on the environment. The volume of a sphere is 4/3 of pi multiplied by the radius r to the 3rd power. we're supposed to write an expression that represents the volume of a sphere. So this is just going back to translating. We understand that 4/3 I'm going to write as a fraction. We know that of means that we're multiplying. Pi, which is the number 3.14, they said multiplied again by the radius r to the third power. So I'm going to put to the third power. So sometimes a good idea to go right up into the problem and translate up there. So now I can go ahead and put that all together. I have 4/3 times pi times the radius to the third. So I just took out those multiplication because I understand that all of those variables are being multiplied in that term. All right, now we're supposed to find the volume of the 3-foot radius sphere used for SOS. So they tell me that R equals 3, which means that I'm going to go back up into this problem. 4/3, again, understand pi is a number. Now I'm just going to put a 3 in for that radius, and I'm going to take it to the power of 3. Going back to my calculator, showing you a couple more things with this. One unfortunate thing about TI-83s is it doesn't deal with fractions very well. So in order to put that fraction of 4/3 in, I have to hit that parenthesis and actually write 4 divided by 3. That way it understands that I'm dealing with a fraction of 4/3. Okay, pi. Most of the time we like to see it as 3.14, but this calculator has a pi button, so we might as well use it. So I'm going to hit the second button in my caret, and notice it throws in the pi. Then I'm going to put parentheses 3, caret, close parenthesis 3. And I'm going to go ahead and hit enter. And of course my calculator didn't like that. Why not? Oh, because I have this, give me a second. I put the power button inside. There we go. Close parenthesis, then put the power button. Okay, so it looks like it's about 113.1. I need to see what I'm dealing with. 3 foot. So the volume of this is 113.1 feet. Knowing in geometry when I'm dealing with volume, the label is cubed. Okay, so again, getting used to this calculator, which does not like me today. Hopefully it likes you a little bit better on guided practice number 5. So go ahead and try that one out. These type of problems sometimes get pretty wordy because there's a lot of information going on there. So I would always recommend reading it through one time and then reading it again and slowing down and chunking it up to understand what we're talking about. So we have 539.2 fires that start with debris every year, and they're representing those years by D. We have 129.1 that are started by campfires per year, and they're representing that by C. So we're supposed to write that algebraic expression for the number of fires for a certain amount of years. Well, it's 539.2 per each year of debris, 129.1 for that year with campfires. Now, it says how many fires would there be in 5 years. So we're actually going to substitute that 5 in for both of them because it's representing the same amount of years. We're just multiplying it by a bigger number because of those debris here. You did end up with 3,341.5. Well, we can't really have half of a fire, so we're going to round that up to 42. Okay, again, order of operations, pretty straightforward and simple, just maybe getting used to that calculator, how it works, understanding how to substitute numbers in for values, for variables. All right, you should be ready for the assignment for this section.